Hi guys, welcome back. I made this Congressional bill parser. For this project, I look at keywords and then dollar amounts associated with keywords. So basically, it searches through Congressional bills for a keyword that you put in. It could be any keyword, and then it finds dollar amounts within the context of the bill that are associated with the keywords. So if you want to find the money associated with maybe education, you can do a keyword search for education and then find the dollar amounts within one bill or multiple bills. And for this example, I'm using several omnibus bills over the past decade or so. So this program is in a Colab. I set this up here so that you can run this program yourself. All that you're going to do is click these play buttons over here on the left-hand side, and it's going to run the code. It's going to generate CSV files and plots within the Colab environment. So not only does this program find dollar amounts associated with keywords, it finds the context, it downloads all that information, and it puts it into a CSV file. And not only does it find dollar amounts associated with a keyword that you put in, it finds dollar amounts associated with other words that are related to your keyword. So semantically similar words. In other words, words that have similar meanings to your keyword. And at the end, it plots over time in a line plot or bar chart. So you can compare trends over time, or you can compare keyword searches with other keyword searches. So I just ran this first block. This is the import block. What you're going to do after this import block, go to my bill folder here, click this link, and you'll see my Google Drive full of Congressional bills. These are the omnibus bills. I even included the big beautiful bill that's coming out soon, right? So you can analyze that bill that's been in the news recently. The final four files here, these are text files. They're all text files. But these last four files are for the semantic word search. When we try and find words similar to your keyword, you're only going to use one of these files in the program. But let's go ahead and run the program first before I describe it and explain everything. So I ran the import block. I'm going to mount the Google Drive. So when you open my Google Drive bills, I want you to create your own folder called bills. So you're going to click and drag and select all of these files and move them over into your new. So what you're going to do is click new folder, call the new folder bills, just like me. Then move these files into that folder. And then you're going to connect your Google Drive folder to Colab. Why do I do it this way? Well, these files, if you look at them, they're large files. The glove model files, some of them are almost a gigabyte large. I think it's just easier for you to have these files first in your own Google Drive than for me to host them on a platform. It may not be super efficient. So we've mounted our Google Drive to Colab. We now have this folder now in Colab, and in Colab it's going to have our bills. Click this folder here on the left, and you go to bills. You'll see all of those bills and the glove files from the Google Drive. Let's run the code block here for global constants. It's just going to take a second. We're going to run the code block for functions. Super fast, super easy. For functions, we're just defining what functions we're going to be using in the main execution block. We're not doing any tedious executions or operations. And then we have the main execution block, and I'm going to hit play. You can see here it's asking for a keyword to search. So I mentioned education. Let's go ahead and look at that. I'll type it in and hit enter. Colab takes us back to the top of our code block here for the main execution block. I'm just going to scroll down, and we're going to look at the output. So you can see here as the program runs, it's searching through those omnibus bills, and it's finding the instances of our keyword education. You can see that in pink here. In green, we can see the dollar amounts that are associated with education, our keyword. You have 40 million here. Public institutions of higher education, or pay up to $2,500 each year. And at the top of each of these little keyword searches, we see the date for the bill itself, followed by the date. This is the file name. We have the division and the title in which the keyword was found. And we have some of the text surrounding the keyword. And so the search is complete here, and we have a total matched dollar amount here. We have matched contexts with dollar amounts, and this is for the search of education. Then it asks you, do you want to find related matches for education and extract dollar amounts? So we can search for words that are related to education. And that can give us a good idea as well, like how much money is really going toward education, even if it's not really the word education. Actually, I'm just going to hit Y and then hit enter. Now, it says to set a minimum similarity score for semantic matches. What is the meaning of a similarity score for semantic matches? Well, you can think of it kind of like a probability, like the probability that we find a word that's related to education within the text and that it's actually related to education. The default here is going to be 0.75. The higher the number here for the similarity score as our threshold, the fewer semantic matches we're going to get. But the matches we get will more probably be related to education. So I'm going to set this to 0.8. Now, if I wanted more matches for related words, I could set this threshold really low, like 0.5. And I would get lots of matches, but the matches may not relate as well to education. So 0.8. We hit enter again and it brought us back to the top of the main execution block. I'm going to scroll down to the output. And I put this in as an option because this takes a bit of time to run. The semantic search has to do a little more processing. It takes a little bit more time. It's using those glove text files and it may take several minutes. We're going to let this run here. Okay, and that search took about 30 minutes. So let's take a look at some of these keyword matches that are semantically related to education. So these are in blue. We have health programs, programs itself, services, development, public, program again. So the word education, very general. You're going to get lots of matches, and the matches here, also keep in mind that it's trying to match with words in congressional bills. So we're also limited by the text and language in the congressional bill. And so we're finding these dollar amounts associated with the semantically related words here. And I just want to look at education for now, but we can do searches for multiple keywords. So I'm going to hit enter. And that exported the context and the keywords and the dates to a CSV file, and that'll be over here in the file here. We see all keywords, dollar contexts, all keywords and totals by bill. I have in a CSV file the keywords and the dollars and the context surrounding like this text. So I'm going to click this and just show you real quickly. So I double clicked and Colab gives you a brief kind of glimpse at the CSV file. You can download this as well if you left click the three dots, just go to download and then you can view this in your program of choice. But you can see here the first column will be the keyword. You could have multiple keywords in this CSV file, you know, depending on what keywords you're looking for. The bill date, the bill file name, the division where the keyword was found, the title, the context, and then the dollar amounts here as well. And then in the final column, I have the total. And this is the total associated with that keyword within this bill, on this bill date. And then I total them up as well. I total the keyword searches, the dollar amounts and whatnot by bill. And I just have the total matched amounts here as well. So maybe you don't need a very detailed look, but you do want the totals for each bill associated with that keyword. And so that's what I found here, and you can see it in this CSV file. So I'm going to close this for now. Our program isn't actually done yet. At the very end, it asks if you want to plot the dollar amounts associated with the keywords. So we just looked at education. We're not really comparing with other keywords, so maybe a trend over time, like a line plot, that would be more beneficial. So I'm going to type in line and hit enter. And once again, it brings us to the top of the main execution block. I'm going to scroll back down to the output, and here's education over time. These are the dollar amounts associated with education. And I have this nice nice time series line plot, and in the background I have it shaded by the administration, like the Democratic or Republican administration. And so this previous area here would be Republican. This was during the Trump administration. The blue here would be Democratic for the Biden administration. You see a trend for increasing appropriation to education in these omnibus bills. with a peak in 2022. And perhaps we can kind of think, well, what happened around 2022? This was the time when we were spending lots of money on education and health and whatnot for COVID, and then a decline in 2024. And now the program is complete. This was an example of my bill parser program with just one keyword search. Let's look at several keyword searches. We'll compare the keyword searches together, and perhaps we can also see trends over time. So actually, I can just execute this main execution block again. I'll hit left click here. We'll run the program again. Let's search for something like more specific. Let's look at Ukraine. We're going to look at dollar amounts associated with Ukraine. You can see that was a faster search. So the more specific your keyword, it's likely that the program will take less time to execute. We can see the instances of Ukraine here. This is in the bill from 2019. And we have money for the Defense Security Cooperation Agency for Ukraine Security Assistance Initiative. And here's another match here for Ukraine, but there are no dollar amounts found associated with the keyword Ukraine. So those keyword matches with no dollar amounts are collected as well. We can go to the file here and see no dollar matches for keywords. And if we double click this just to take a quick look, this was for education, but you can see we have that context right here. Even if there are no dollar matches, we still find instances of the keyword. Download those instances in a CSV file. I made this program because I was curious about the money being appropriated, but then I thought sometimes you still want to see the instances of the keyword in whatever bill, and so that data is exported as well. I'd like to find semantic matches. Yes, let's go ahead and search for those. Now the default is 0.75 for the similarity score. I'm just going to hit enter, and that's going to be the default. Colab brings us back to the main execution block, and that's going to run here. Now with a more specific keyword like Ukraine, this shouldn't take as long, but I'm going to scroll down to the output area, and we're going to wait here. Okay, we're back. That took slightly less time, but it appears there weren't any semantic matches for Ukraine. The reason for that is that Ukraine is a proper noun, and the glove model doesn't really match semantically related words with proper nouns very well. Let's search for another word, and we're not going to do a semantic search this time because we're probably not going to find any matches, but let's do a search for another country, maybe like China. We'll see what comes up with China, and then maybe we'll do one more country after that. And you can see the keyword search is much faster. I'm going to hit no here for the semantic search. And I think I want to see a bar chart comparing China and Ukraine together. So I'm going to hit enter and then put in bar, and it's already completed. Let's see our output. And we still have the result for education here. I just ran the main execution block again, which is fine. But I really wanted to compare Ukraine and China. But you can see here, with a bar chart, we can compare keywords over time in sort of a bar chart type format. And we can really compare dollar amounts. Lots of money going to education, significantly less money going to Ukraine, and then very little going to China. Let's look at the CSV file real quick. We can see semantic matches. I'm going to go ahead and download this. We'll take a look at it. So first we're looking at no dollar matches for keyword. These are all of the matches for the keywords that didn't find any dollar amounts in the context of the surrounding text. And I put this in a Google Sheet. And so you can see here, we have our keywords in the first column, bill dates in the second, bill file names in the third, divisions, titles, context, a note here as well. The context here this will be all of our text that we found surrounding the keyword. And the keyword in this case is education. We're still going off of that previous search, and the CSV exports are for all the keyword searches until we run the whole program again. From the beginning. So we have all of this context for education from our keyword search for education. Here you can see the keyword education, food for education and child nutrition program grants. And you scroll down here, you can see all of the rows. Now the rows here, they're not evenly spaced because of this context column. You can easily change that in Google Sheets by highlighting the rows, right-clicking, and then resizing the rows. So I specified a row height of 18, and that gives us a little more compact look. And again, these are for no dollars found. Let's look at another CSV file that we exported. I'll go to all keyword dollars. And again, we have these oversized rows. Let's go ahead and highlight some of these rows and resize them. Specify the row height to 21. That was the default here. And here you can see the keyword education, the bill date, the bill file name, and all the other information here. The dollar amounts here are from the surrounding context from the keyword. And then in the final column here, we have the total. This might be a little more efficient if you're going to plot some keywords over time and the associated dollar amounts. You may not need every specific instance of the dollar amounts here and the context associated with them. Sometimes you just want the total, so I made a separate CSV file with just the totals. Now if we scroll down here a bit more, say to row 321, we start to get Ukraine keyword matches and then China matches. We'll highlight all of these rows and we're going to resize them. There we go. So we have Ukraine here, we have the dates. You can see a lot of the dollars being appropriated to Ukraine happen in this 2022 bill. Well, we do have some instances in 2019 and 2018. And again, if you want the context, you can just double click this cell here under the context column and you're good to go. And again, so let's look at this. This is to assist refugees from Ukraine and for additional support for other vulnerable populations and communities. Let's look at the context for the keyword of China. To counter the influence of the government of the People's Republic of China. So this is money being spent to combat the influence of the Chinese government. This is to counter the malign influence of the government of the People's Republic of China. And education. Let's look at some instances of education here. Here's some money going to promote the education of the blind. Here's some for school improvement. So again, you can do this for any keyword you like. The bills I have in this program are for omnibus bills, but you can use any bill you like. All you do is you find the bill, you can go to congress.gov. Here, search for a bill, and then just get the text for the bill and save it as a text file, .txt. Here's the bill right here. Several ways you can do this. You can hit Control A, copy, Control C, and then Control V and paste. And you can paste it into a notepad or Word program and then save as a .txt. And then once you have that bill saved, put it into your Google Drive, the one you created for bills. Name the file as the bill. For instance, this one is HR1. This is the One Big Beautiful Bill Act. So put in HR1 underscore and then the year, the month, and the day. And then in the program, you'll want to edit the global constants. Here I have bill file names. I loop through bill file names, so you can just put in the bill file name here as another bill, or you can do it separately. I have this one set up for one bill, for instance, the Big Beautiful Bill. Just hash out this part here, and then now bill file names is just one bill, and we can search through just one bill. Let's go ahead and do that. I'm going to run all of the code blocks again. Make sure you run global constants again because we changed bill file names here. The functions don't change. And let's look for something in the Big Beautiful Bill. What might be interesting is like border spending or border protection, something like that. So let's put in border. I'll scroll down to the output. And sure enough, we see border protection for fiscal year 2025. We have 20 million here to remain available until September 30th, 2029. We have keyword matches with no dollar amounts as well. Remember, we're exporting that context to a CSV file. Here's another million. Here's 500 million for enhancing border security, combating trafficking, including fentanyl and its precursor to chemicals. And now the bill file name here and the date, it's just for that one bill. HR1. I'm going to hit no for semantic matches. I'll do another search here. Let's look for something like Medicare and maybe another search for Social Security. I'm going to hit enter to quit, and I want to see a bar chart. We're just looking at one bill, so we don't really need to see trends over time because we just have one date, but we do have multiple keywords. So we do see here lots of money going to the border, but not so much money going to Medicare or Social Security. It doesn't mean no money is going to these other services. It just means these are dollar amounts appropriated in the HR1 bill. So this was just a side project for me. If you check out the functions of this program, they're pretty straightforward. I won't go into detail about the functions, but you can certainly check them out. The functions here, a lot of them are for cleaning texts, finding the divisions and titles, and making sure that we eliminate a lot of the noise. It's important that we find these divisions and titles and then export them to CSV files. We have some functions here to load the glove model. Glove model is the part of this program that takes a lot of processing and it will take a lot of time. Keep that in mind if you want semantic matches and dollar amounts. And then finding the context and paragraphs and displaying them in a useful, user-friendly way. And then the plots, of course, the line charts and the bar charts. Now, when you do a project like this and you make a program like this, ChatGPT is very helpful. ChatGPT will create functions for you based on what you want to do. Say you want to create a line plot or a bar chart. And it's easier for ChatGPT to create functions, define functions, which then can be edited separately. And then you just run the function in your main execution block. It's more efficient than kind of going back into your main execution block line by line and trying to find part about the bar chart or the line plot. You can just find all that information in the function block, and it's much more efficient, and you can easily make changes to your program without changing the overall execution block. So that's the key with using ChatGPT, kind of segmenting your work and making it easy to make changes and updates without destroying your whole code or without mixing everything up. And I hope you guys like this. This was just a side project for me. If you want to see more projects like this, comment below, send me an email. What would you like to see? What are some ideas you have with using Python and natural language programming? I thought this would be a useful program to parse really large congressional bills. Oftentimes these bills are introduced or they're up for a vote in Congress by legislators with very little time to read through and parse through hundreds of pages of text. So my thinking was this would be helpful or easier to kind of make sense of really large blocks of text. If you like this, like the video, subscribe to me, and leave a comment below. Tell me what you think, and that's it. Thank you, guys.